Hello there, this is the Lab Hub. My name is Nick and welcome back to our lessons. And today we're gonna talk about circular motion. And this is a really complicated topic for much students, and many of you may not really understand what is this? What is circular motion? What is this and how does it work? That's okay. That's totally fine. And I'm not gonna tell you that this is really easy or that will be easier. No. In the future, there will be a curvilinear motion. It's much harder than circular motion. So I'll try to make it clear. And we'll start with the circle. Obviously, we need a circle to do circular motion, right? And this is the center. We got a point A here and a point B here. So, what we got? Sure, we got an angle. So this angle, it's angular displacement between these 2 points. And delta angle. To make it clear, delta angle, so change in the angle from point A to point B, this is exactly what angular displacement is. And angle can be calculated like this. Yeah, angle of B minus angle of A. That's not so hard. It's not so complicated to understand. And we also should keep in mind that point A moves like this. So what we also maybe should know is that angle calculated in radians, or a full name is radians. It's a high school trigonometry. What we also should know, velocity, right? If the point A moves, we need to know its velocity. So how can we find it? We know that velocity in a linear motion can be calculated like displacement divided by time. Yeah, sure. But what about, let me mark it. Yeah. But what about angular velocity? Angular velocity is this sign and the above vectors. So angular velocity, it's change in angular displacement divided by time. Yeah, it's super clear. Angular. So this is angular velocity. And while the linear velocity is meters per second, angular velocity is radians per second. Right. Maybe there's some similarities between these two velocities. Yeah, there is. So linear velocity equals angular velocity times radius of the angle. So for instance, this radius of this circle is 5 and velocity is 10. So the linear velocity of point A, it's got to be 50. Right? Right. So this formula is really, really useful. And therefore, we can do another circle and another one inside this one. So we got a point A and we got a point B. Let me ask you a question. Which velocity of point A or point B will be greater? And you should ask me which velocity, linear or angular. So for both of these, an angular velocity will be the same because they're both moving in a circle, right? Right. So angular velocity of point A equal angular velocity of point B. What about linear velocity? Radius of circle 1, for instance, is 5. While radius of circle B, for instance, again, is 10 centimeters or 10 inches, no matter. So therefore, velocity, linear velocity of point B is greater than linear velocity of point A, right? Right. So another thing we need to know about is period. T is period. What is period? This is time to complete one cycle. One cycle is a full spin of some point around the circle. And the formula can be estimated like time divided by cycles. So we got some time, we divided by amount of cycles, and we got a period. And another thing, it's totally opposite to period, is frequency. Sorry. Frequency. Right. And this is small f. And it equals cycles divided by time, yeah. So this is numbers of cycles per second. And now we are getting a few new formulas. At first, we can find period with the frequency. Why? Why not? So period equals 1 divided by frequency, yeah? Yeah, it's logically. And therefore, we need two more formulas. At first, angular velocity equals 2p frequency. And therefore, angular velocity also equals 2p divided by period. Why? Why not? And let's now talk about acceleration. So in angle, in some circle, we got a tangential acceleration and we got a centripetal acceleration. So centripetal is always aimed on the center of the circle. So if object is here, we got a centripetal acceleration looks downwards. And therefore, tangential acceleration looks on the left. Yeah. And since linear acceleration equals change in velocity divided by time, angular acceleration equals change in angular velocity divided by time. How can we find like these velocities? Centripetal acceleration equals angular velocity squared times radius. In tangential acceleration equals angular acceleration times radius. And sometimes we will use the term that sounds like acceleration resulted, AR. But it also, you may face it in some books or in some papers. This is acceleration net and net acceleration. These are equal to each other. And acceleration resulted equals centripetal acceleration squared plus tangential acceleration squared. And so therefore, we can imagine it like this. Yeah. Tangential, centripetal, centripetal, and this is resulted. Sure. Why won't we? So another thing we need to know is centripetal force. This is centripetal force, and this is a force applied on an object. Yeah, we know it. And since, right, at first, we need to know that some force is ma, right? But this is for linear scale. But what about angular? Because of the formulas we have described here and here and here, we can say that centripetal force equals mass velocity squared divided by radius. Or it's just equal to mass velocity squared radius. Just in some cases. So another thing is tangent. Let me use another space. So we got two types of circles we will use in all middle school physics or sometimes even a high school physics level. So this is horizontal circle and vertical circle. What's the difference? Let me explain. We'll start with the horizontal because this is the easiest one, I think. And at first we need to know some new terms. This is length. Length of some string or some loop, like this. So radius of this circle is always equal to length of some string sin of some angle. This is only for horizontal circles. And for vertical ones, radius equals to length of some string. So in this case, in a horizontal circle, we need usually to know tangent of the string where some ball relies on, and tangent of the string equals mv squared divided by radius. So it equals centripetal force. However, there is also some new forces. Let me show it to you on this. We got this, and this. So this is tangent. Sorry. This is tangent, like total tangent of this string. This is ty, tangent y, and tangent x. So in this case, tangent equals to root of tx squared plus ty squared. How can we find these amounts? Like, how can we find out? Tx is always equal to mv squared divided by r divided by radius. So again, centripetal force. And ty equals to mg, just a free fall. That's all you need to know about horizontal circles and tangent in them. What about a vertical circle? We have 4 positions in it, and for each position there's different formula for tangent. So at this point, at the very top, tangent equals to mv squared divided by radius minus mg, because the ball is going down. It will go down soon with with using a free fall. So this is why minus mg. At the middle here, at the middle of the circle, tangent equals to mv squared divided by radius. And the same case here, tangent equals to mv squared divided by radius. Because it's literally in the middle and we don't need to use an mg. What about bottom? It's the opposite for the top, so logically t at the bottom equals to mv squared divided by radius plus mg. Because you got some energy, some kinetic potential no matter from the fly from the top of the circle, and at the bottom of the circle the energy at its top, so it goes with some additional energy due to gravity. This is why we're adding a gravitational force. And one advice I want to give you is don't forget about the conservation of energy equation. I'm sorry. Because in many problems for this kind of circles, you will need to calculate probably velocity at the bottom when you know tangent at the top. So in these cases, you will need to use the law of conservation of energy. This is very usual, and don't forget about it in all kinematics. So that's all you need to know about circular motion. See you next time.